So here is a picture of the actual chemical formula for the structure of DNA. It looks super complicated, but if you're a chemist, I guess it's not. So there's sugar over here. You've got your phosphate, and then here are your nitrogenous bases that I mentioned: the thymine, guanine, cytosine, and adenine. The bases are read in threes, and those threes then make an amino acid. So that's how the code is read in threes. Here's a picture of DNA that kind of is a little bit more clear. So you can see as it splits, A goes to T, C, G, etc. And then what I said before was the ribosome will make these proteins, these nitrogenous bases, and they come and match up, and you have an exact copy of the DNA. So the way that I remember what is paired with what is by remembering that atoms are tiny and candy is gross. So A goes with T and C goes with G. You guys may come up with another one. Often kids do. So you can imagine then with all of this code that something can go wrong. And when something goes wrong, that's called a mutation. Not all mutations are bad. That's the thing to remember. Not all mutations are bad. Some are, and they can cause disease. So here we have a sentence. This is a full sentence here. And what I want you guys to do is just look at it for a moment. This top one right there, beginning with an A, and tell me what you think that says. See if you can figure it out. There's something going on in there that you may be able to check out and figure it out. I'll give you a minute. So what's happened here is there's been a deletion of one of those bases. And I can't find my pen. So what this actually says is if you were to put an O right here, so that is what got deleted. Now these letters obviously don't match the A to the T, the C to the G. It's just an example of what happens when things get garbled. So right here, it's Amy got the red hot pot off the log. So that's how it should have read, but you saw how it obviously didn't. So that is one form of a mutation. The other forms are when that was a deletion, when there's an insertion. So somehow the chemical template gets messed up, and an extra base is inserted, or instead of the base that's supposed to be inserted, there's a substitution. We have the ability, all of our cells, to fix this DNA, and our cells are doing it all the time. We're being bombarded daily by chemicals, the sun. Wear your sunscreen. That will help not degenerate the DNA in your cells and potentially cause cancer. And that's what happens over time with these mutations. It can possibly lead to disease and cancer.